Great. Yeah. So I'm gonna talk about our new client library of ServiceX, and I wanna start with what is ServiceX? Uh, so ServiceX is a scalable data extraction and transformation and delivery system, and it's deployed in Kubernetes cluster. And this, yeah, simple or maybe very complicated diagram shows, I mean, what is going on inside ServiceX under the hood. But this is about basically on the I mean server side activity. So let's because but to basically to explain what we have done for client library, maybe it would be nice to give some context of the backend, what is being done and what is going on there. So let me follow like the orange line, which is the flow of the data, like our, I mean, event data from collected our detector. So basically ServiceX delivers from grid or remote site, like so NeoS storage or XOT storage, or like multiple tier 2 or tier 1 grid sites to a user. Or more precisely, ServiceX writes files into the object store inside a ServiceX cluster. This is internal storage of ServiceX, and then deliver to the user, or user downloads files, or user download the URLs of the files in the from this object store as soon as it's available from the ServiceX. And the thickness of this orange arrow basically reflects the amount of data over wire. So basically, ServiceX is not designed to like download file from the grid. It is effectively reduce the data to the user based on the query, or based on the selection or filtering by user, given by user. So the ServiceX itself, or ServiceX engine, so-called transformer engine, takes the files out of from the grid, but it effectively does something and then write out some fraction of data, or fraction of data into the object store, and then stream to the user. And as you can see this in this dash gray area, usually ServiceX is often co-located with the grid system to maximize the network bandwidth from the grid to grid to the ServiceX backend. And this so-called X cache is preferable because some often frequent access data set is cached to this X cache system, and then it reads much faster from the X cache, but it's not a requirement. So it can also read from the external side, but that's usually usual practice of ServiceX. And the core of ServiceX is a so-called transformer. There are multiple transformer paths shown here, Kubernetes paths here shown here. So it's ServiceX, as you can see here, it consists of multiple microservices, each with essentially Docker containers, and all the blue ones are basically in a running state, so it is waiting for the request, or waiting for any action taken from the user. But this transformer shown in red color is so-called dynamically created path. So it basically follows the Kubernetes horizontal path scaling. So once there's more, I mean, more info files from the data set, it may basically spawns more transport paths, and then if it basically do some certain criteria, or a certain condition to scale up or scale down, and it basically does that automatically. And essentially what user, or what the main focus of my talk, which is client library, is where is made by is where ServiceX request is made. There's a ServiceX web API part, and then we basically talk to this ServiceX web API part to make a request, and also check the status transformation, and also ask download and so on. And ServiceX request basically take one input data set or list of files. And as I mentioned earlier, yeah, ServiceX is heavily scale, yeah, transform paths automatically. So it's much more preferable, yeah, or desirable to, yeah, to utilize that feature. So it's, yeah, not quite recommended to run on single file data set, but it's, I mean, ServiceX doing fine with that, but it is designed to like provide, yeah, multiple files, data set with, yeah, multiple files, and then leave ServiceX to the scaling. And also, yeah, the diagram I put here, yeah, in the machine anywhere is like this, yeah, is to I mean to show, yeah, ServiceX is, yeah, since it is just HTTPS request, so you can make a, I mean, ServiceX request anywhere in the world. Yeah, if you have like ServiceX client library installed, and then if you have like ServiceX the YAML, yeah, YAML file, yeah, that includes access token. And it's, yeah, so although, yeah, you can do like, you can, yeah, deliver some like some your, yeah, smaller selection, yeah, into the machine inside the analysis facility, or, yeah, within this, yeah, within this computing cluster. But also you can like, yeah, deliver to your, yeah, local machine or local cluster, or even to a laptop for small tasks. And as I mentioned earlier, yeah, we basically need ServiceX client installed from Python, yeah, Python client installed, and then you need a ServiceX YAML file, which contains access token. So the second part is can be obtained from the ServiceX website, and you can just copy it to your home directory or your working directory to make use of that. And this is like the screenshot of the current ServiceX deployed at Chicago analysis facility. And, yeah, though that this endpoint is basically limited to Atlas users, because, yeah, it basically give access to the Atlas event data. And as you can see here, under your name, under my name, if you click profile, and then you can download basically ServiceX.yaml file, yeah, by just simply clicking this icon. Yeah, that's about the backend and or the server. Now, yeah, let me go dive into the client library. So client library is Python library, and essentially it's for users to communicate with ServiceX backend or server to make a delivery request, or like checking the status transformation or the handling of the output files. And as you can, I mean, saw from the diagram above, the most fundamental component of ServiceX request, it should be the data set and the query. So data set is essentially the, yeah, what you want to run on, or what you are interested in. And query is essentially, since ServiceX is like doing some kind of data reduction, so it should describe what user wants to run in Transformer. And, yeah, those two parts, I focus really on those two files and that is kind of like one of our design goal, as I mentioned here. So really minimize the boilerplates, because we, yeah, had to define, yeah, quite a few things to make a simple query. And now we really focus on those two items, and, yeah, on our client library. And the other goal of the other design goal of new ServiceX client library is a programmer interface. Essentially, it's integration of ServiceX data binder. I gave a talk, yes, sometimes in maybe Pineapple or so. But it's essentially, bring that, yeah, Python package. Its data binder is like a wrapper package of a client. It was wrapper page of, yeah, previous client library, but now basically bring all the features into client library with some, yeah, significant improvement. And also the other thing is, the other goal is like, we want to have really strong typed by using Pydantic. And installation of ServiceX is just pip install ServiceX, and as you can see here is still ARPA release. So yeah, there are still some things we we need to make it work. And yeah, since by clicking that icon in the web page, I have basically downloaded a ServiceX config file and then install ServiceX. By having those two things, I'm basically ready to make a ServiceX request. So yeah, ServiceX, let me start with like very basic thing. So deliver a branch or a column from a data set on the grid. So yes. Yeah. Let me import ServiceX first. And then here is our new ServiceX request, or the interface we developed for client library. So now it basically there's one sample defined and named raw PyHap, and it's defined as in this spec object, which is a dictionary. And one data set is specified. This is data set, but this data set is Rusu data set, and I need to put the name of Rusu data set, and also define query. So I mean, apart from this data set and query, I need to put the name of the sample. That's basically or. And this query is basically, as I described before, it's essentially the query sent to transformer to run all files in this given data set. And this particular query, although I gonna come back with the detail of this new query language, but it basically takes the tree name, which is the name of the tree in the file, and then filter name is to select basically branches in the given tree. And let me try to deliver my ServiceX request. Just asking ServiceX.deliver and passing this spec object is, so it basically prints like the name of the sample I defined here, and there are two progress bars. So up is for transformation and below is for the download. Okay, it's there. Oh yeah. Yeah, transformation is done. There are only three files in here, and download is, although it's there's some issue with the progress bar from the backend, so it's it's done. This is something we need to fix. And there are three files in this object. Basically, it returns is, so it's a dictionary with the key of the name of the sample I defined here, and the value of this key is, it's a file set. It's a list of files. So the first file is this root file, and I can easily inspect this root file just by checking this content. So this is electron PT sometimes 2 electrons and no electrons and so on, and 11K events. So it's really only a few lines of Python script brings the data from the grid, and it's fascinating and on demand and interactively. But let me really go through what kinds of data set and queries are supported by ServiceX. So the data set, the type of data set we support is Rusu data set, and also we have like XRT protocol accessible data set, and also we added like some of the data set. So this Rusu, if you look at the Rusu class, it takes the name of the data set as a string, and also you can specify how many files you wanna run over, or how many files you wanna take out of this root data set, and basically you can limit number of files and do some tests. If you don't specify it, basically run over everything in the data set. Or the other option is file list. File list basically takes a list of string or a single string. Yeah, so you can pass xroot pass or list of xroot pass to run files xroot. And sort of data is data set. It's there's some tag. To be honest, I never tried by myself, but it's you can the data set is can be set by data set number, and also you can also limit the number of files you want to run over. So there was types of data set ServiceX supports. And query is bit complicated, but it's essentially I mean, it's really something you need to know, because that is essentially what is running into the transformer. So query is a representation of what user wants from input data set, or like I put in the previous in above, like query really specify what you want out of the input data set. Like I want this column out of this tree, and user query is actually it's translated into the code that run in transformer. So the query that means query is really input data dependent. So you cannot use I mean the query for like flat root table to like for the on the Apache Parquet file and so on. So the list of queries we have at the moment is following. So we have like funcadl queries for Atlas data sets. These are all for Atlas data sets for different releases. And for CMS 1.1 AOD. And bottom threes are for the on the root queries. So for root using root, we have like 3 different types of queries, which is using funcadl query, or you can pass really vanilla Python function to as a query, or in the new addition, which is raw query. So let me walk through the root queries, because the funcadl query Atlas XAD or Atlas queries are not quite implemented in our new client library yet. So let me go through this root queries. So the root raw query, also shown in the above examples, it's like new addition. It's new query language we implemented. So, but under the hood is essentially really calling root.tree.arrays function. So you can basically makes use of many arguments from that function. And this raw query, it's a bit different. It also provides bit different features. It's a dictionary. It can be a dictionary or a list of dictionaries. So there are 2 operations you can basically pass over. There are 2 types of things you can do with raw query. First one is really querying, like in the previous example, you can really set like I want something out of this tree. And the other thing is we added this feature because there are some histograms we wanna basically download, but using ServiceX, but it wasn't quite straightforward. So we added this copy histogram subclass to add that feature. So basically this is yeah, there these two dictionaries are for each I mean each operation. So this first one is for the query like before. So set tree name, or and also filter like all the muon view dot objects and row number and or jet pt objects. And also you can apply some cuts with familiar language. And this copy histogram, you can also basically copy all the histograms, like listed here, using that. And also, more details on this Amuro query grammar, can be found here. This is the our work in progress documentation. Read the doc page. So this is the same query, but basically tree name is nominal, and I wanna basically filter this electron PT branch out of that. And the other query basically it's really different language doing the same thing, but the other query is FunkADL query. This FunkADL or functional analysis description language is it's like a powerful querying language that has been supported by ServiceX for quite a while, like from the beginning of ServiceX. And this FunkADL query basically supports like select for column selection or where for filtering. But in addition to those basic operation, you can also write quite sophisticated query. And one addition to in this client library, in this ServiceX client library, is like this from tree method. So this method is basically specify tree name in the query, not in the ServiceX request. So although it's bit a few years ago, but it's still I think grammar is pretty much the same since then. So there was talk by Mason about the details of the FunkADL, and you can learn more about the FunkADL language there. So this writing a FunkADL query is, so I need to set a tree name here as a from using from tree method, and basically do the same thing as raw query. So I select only electron PT branch out of the input file. And last thing for the Amrud backend is Python function query. Essentially, it's really pass Python function as a query. So, but since user can only pass like string. So what is being what is being run in the ServiceX inside the transformer is like a Docker container. So you cannot import every package you want, but it is limited by like Umroot or vector, some some physics related packages. But to be honest, this is this Python function query is like more experimental purpose, and very likely to be discontinued. But it's for the experimental purpose, I think it's very useful. So it's really you define the function and then import then do whatever you want here, and then return the branch, or you can return like occur table or so. And this query essentially also does exactly the same out of nominal tree, and then reading this electron PT as an array, and then return that. So as I mentioned, all three types of queries, it's just different language doing the same. So basically you can choose whatever works for you and whatever better for you, and does the same. It just from root files and select the branch electron PT. We don't know this electron PT. I don't know whether you noticed from this from the previous ServiceX request, but it's, I mean, have analysis is often need more than one sample, one sample. So yeah, it definitely want to sample multiple sample. So in this example, the sample block is it's his list. It's not a list of dictionaries, not a single dictionary. So you can basically add as many samples or as many dictionaries as you want. So this dictionary is like a data set and a query pair with name. That's a minimal requirement. So you need to have you need to specify what is data set and query, what is the query, or what is the information you wanna extract from your data set. And you can list multiple data sets also. Yeah, although in this example I put basically it's the same data set, but you can basically multiple different data set and different query. And the ServiceX basically client library makes one ServiceX request per dataset per dataset query pair. So each dictionary is correspond to one ServiceX request. So there are gonna be 3 ServiceX requests. But again, it's much preferred to have like more files in a request to utilize Kubernetes horizontal part scaling, auto scaling, and then having multiple requests for the same query, and each query with one file or so. So by running this, now I have like two transformation or two service request is going on, because one is already done basically in the previous cell, and it's actually cached locally, and so it is already done. So it takes the output from the local cache, and only those two which are not done yet is running. So these two are running, and then and also shows, since it's the same data set, same number of files and so on. Yeah. And the second design goal I put there was like interface of having interface of YAML, and the main motivation was like, okay, it's really cool to deliver this only interested columns from the grid storage in this zip notebook, but in real analysis, it often becomes quite messy. Like having every configuration of your request in a notebook or in a Python code can be really messy. So that basically makes us to bring all the ServiceX data features into the client library, and also with I would say a significant improvement of user interface. And one of the goal is really seamless experience with YAML, and also the other way. So this is an example of YAML configuration file for ServiceX client, and this is actually not the bug we have. Our backend is not running great at the moment. So this is the YAML file, YAML interface or YAML file input, basically doing the same thing as the first query. So it has the same structure, basically sample its list of dictionaries, and name of the same name, and data set is, and say this data set is a Rusio data set with the same data name, and query is raw query, and also asking nominal tree, and also deliver this electron PT column out of that. And compare with the other, the one, shown in the previous notebook, basically it's really the same structure. So if I hope, it's straightforward also for you. It's the same structure between this YAML structure and this Python approach, and doing sample name and dataset query is basically the same, and also define what dataset type you want to use and what query you want to use. Let me, okay, it's since it's also using the same data set, but it's sort of cached, so it gives, I mean, it gives the output right away from the cache, but it basically runs. So, and this deliver also takes this YAML file as a string, and likewise in this case is deliver, or you can pass spec basically to the same thing. And you might be wondering what is new YAML syntax you might need to learn. There's two things you need to know, which is one is this exclamation mark. This is to declare what data type or what query type it is. You can learn more of this PyYAML constructor, and basically tells which dataset class we want to use and query class we need to use. And these are currently the supported data set tags and query tags, basically the same as the duplication. RUSU data set with this this exclamation mark RUSU and file set and some of data, and also the same name for query tags. And this pipeline, after this is essentially for query tags represent this literal operator, and basically it allows properly interpret multi-line strings. So you need to have this pipeline to write your truncated query as a string here, or raw query, or you can even pass like Python function. You can write Python function underneath. And there are a bunch of optional configurations I didn't really include in the first examples. So there's a definition block to make a sample block more clean and tidy. You can basically use this YAML anchor to set this to set this like define this variable and then use underneath here, or so like for query and or like other types of things like Python function. Like I said, it's basically follow the same same YAML tag, and also this pipe to define Python function, and then you can use underneath and so on. And I didn't mention about general block, but there's a general block, but it defaults the output to the root file when delivery is to your local cache. But you can change that defaults to the Perky file to write out Perky files out of root file, and also delivery of signed URL is it doesn't quite deliver files to you, but it basically returns the URLs at object store of ServiceX inside ServiceX storage, so you can basically consume later on whenever you want. Like imagine you want based on run over files at object store from the coffee, you can just pass this assign URLs to the coffee and it's happily run everything. And also you can specify number of files in the data set, like here. And also ignore local cache if you set local cache to true, and so on. And last thing before I finish is it's although it's strongly typed, so like a typo in the like name or data set, it's checked from the client, but things like in the query itself is it fails basically in the server. So in this case, there's a typo in my filter name. So there, I guess there's no yes, I did import something. Yeah.
Just to say, we are ready over time, including Q&A.
Oh, okay. Okay. Yeah. Yeah. While I'm waiting, yeah, let me finish. So for the future plan, let me finish with the future plan. So for the client library, as you saw, the progress bars on is quite, I mean, stable, and we want to also improve our local caching mechanism. And we are under the read the doc page for the documentation is under construction, so stay tuned. And for the ServiceX in general, yeah, we are basically in the working progress stage for to improve the stability and robustness of ServiceX. Especially, yeah, we learned quite a lot from 200 gigabit challenge. If you know what that means, it's basically we tried like hundreds of service requests on hundreds of terabyte data sets. And we also want to add server-side caching mechanism, and also want to add actually these two transformer as work in progress. And we want to add another types of transformers, which is Atlas topside Toki transformer, and also maybe in the future column joining transformer. Yeah, that's what I have. Thanks.
Thanks very much. So yeah, so this was more really a app specific, a bit difficult maybe to a few of the younger colleagues, but very useful to the other folks. So any questions? We can still have a question or so before going for a break. Going. You mentioned a lot Atlas. What's the vision to make it more of a say versatile slash wide open system where you could maybe reuse parts of it for even for other experiments? I don't know. Is there a lot of discussion around that?
Yeah, I mean, definitely. I mean, since ServiceX really, access to the experimental data, that is why it's that endpoint or that ServiceX deployment at U Chicago is only for Atlas users, but there's one for CMS users at Coffee Casa facility at UNL. And also in principle, transformer can run, anything in principle. You can query whatever you want. So that means for other like type of experimental data or like feathered format as an input, can be also read by that experiment dedicated transformer and so on. But it's that can be added if some input from the experiment.